Hey there, perfect peeps. Are you ready for Data Connect, Firebase's enterprise class SQL database? I sit down with Tyler Crowe to break down every piece of Data Connect. He sits on the Google Firebase team, so he has inside knowledge on what's coming next. Hey, Tyler, how's it going?
Alex, good to see you. How are you?
I'm doing fantastic. Welcome back, everyone else, to CodingCat.dev podcast, season 5. Tyler, do you want to give just kind of like a 5-minute breakdown on who you are?
Yeah, no, I'd be happy to. My name's Tyler. I'm a product manager at Google, and I work on the Firebase team. I manage the Firebase databases, so that's Firestore, Data Connect with Cloud SQL, and the real-time database. So if you're a longtime Firebase fan, you hopefully recognize at least one of those names. And I've been around Firebase for quite a while. I actually used to manage Firebase authentication, and me and some engineers had a crazy idea back in 2019, and that's where AppCheck came from. So I used to be the security guy, and now I'm Mr. Databases. I'm here to talk about Firebase Data Connect today. And I am really excited to talk about kind of the genesis behind it, right? Firestore and real-time database have been the bread and butter of Firebase for a long time. We have over 650,000 active developers on Firestore. But one of the things that we noticed a couple of years ago was that customers sometimes need a relational database. And that was the genesis of kind of the Data Connect working with Cloud SQL solution to give customers that Firebase experience of, great application development without having to manage infrastructure with a relational database powering it. And we know that Cloud SQL is one of the great solutions that many of our largest customers on Google Cloud use today. So that's why we partnered with that team to create this solution, Data Connect and Cloud SQL. So we built Data Connect under a single premise. You write the query, we do the rest. And so let's unpack a little bit about what that means. So the first thing is that when you write a query, you save it to the backend in Data Connect, and it gives you a secure API endpoint that has obviously, of course, integrated with Firebase Auth and AppCheck. So it's kind of secure out of the box. And then we'll generate type-safe SDKs for whichever platform you're building on, whether it be web or mobile. You can have a type-safe SDK that's generated specifically for your queries that will call into your backend and pull out that data or write data as you see fit. And finally, we also have built this for kind of the new agentic era. Data Connect also surfaces with those APIs tools that can be consumed by AI agents. So if you want to improve the intelligence of one of your agents and give it relevant data from your database, given a bunch of different tools, will automatically generate those tools for you based on the query that you write. So everything starts from that first kind of relational query that you write with your data. You start out with the Data Connect service, and of course, you need a relational database in the backend. Cloud SQL is the one that we partnered with, and in the future, you'll be able to connect to any data source that you want, coming soon. And so first thing you need to do is connect your app to your Data Connect instance. And so you can call all those queries and mutations that you defined for the Data Connect service from your app. Then Data Connect will intelligently convert that into SQL under the hood, execute it against your Cloud SQL instance that we help manage on your behalf, and then return the results back to your client. We also integrate, we have that authentication built into those queries and mutations, so it's checked as you're going in. That way you don't have to build in bespoke integrations, and you can manage all of your users in Firebase Auth like you always have. If you want to bring your own authentication system, you can. You'll just need to use the standard kind of custom auth integration that you've used with Firebase Auth in the past. We can go into more details on that if we have more questions there. And finally, we are, of course, integrated with Vertex AI. So if you want to more intelligently search through your database, we'll generate embeddings that help you kind of more intelligently, more like LLM style search through your data to provide those relevant results. We have a couple of new features that have come out in the past couple of months that I'm really excited to talk about. Number one being MCP support for our agents that generate you schema and queries. So you can type in natural language and it will generate a query for you. So you don't even have to have like kind of the know-how to dive right in. You can just ask Gemini and it can kind of let you hit the ground running. We've also added a table view, so you can see your data instead of kind of like a giant JSON blob. You can see it in more of a table, like kind of relational style view. And of course, we've added full text search. I know this one has been long awaited in the Firebase community, and I know it's not for Firestore, but we're really excited nonetheless that full text search is at, that power is at your fingertips now. You can, this has been super, super, super highly asked for, and we leverage Postgres's full text search capabilities that are built into the Cloud SQL database, which give you a lot of different options. And we'll actually go through some of those options in a demo right after this.
I did want to ask you real quick on the MCP side of the house, model context protocol, for those who haven't heard of it. That, like you said, you can call it through Gemini, but in reality, like you can call any model against the tools you provide out through that, correct?
That's right.
Is there any like oddness with the authentication piece to that? Like, do you still have to be authenticated through Firebase only, or can you like send over a different authentication header of some kind?
Yeah, so let me see if I understand your question correctly, Alex. So the MCP server was released by Firebase, and it's something that you install locally on your machine for, right, whether that be VS Code, whether that be Cursor, like kind of pick your favorite place. And it's not always going to be Gemini that's interacting with that MCP server that runs the Firebase MCP server. It could be, right, Claude, Sonnet, like what, Claude, Sonnet, whatever model that you're using. In order to use that MCP server, I believe you have to be logged into your Firebase account because it can actually call and manage your Firebase project. So you'll need to be logged in to your Firebase account in order to leverage that. But in terms of like the model, like Claude Sonnet, for example, calling into the MCP server, the Sonnet model doesn't need to like have an extra authentication because it's happening on your machine.
Yeah, I think I'm glad I asked the question because maybe others are reading this differently. Like I was thinking like we were actually building an MCP server out of Data Connect and being able to like utilize it. So what we're talking about is actually Firebase tools MCP server that you can use other places.
That's right. And so it's actually a little bit of both, right? Number one, we have the MCP server, which are tools which let you generate, right, help you write your code for you, right? It helps you build your application. You can also generate tools, and using GenKit, it has an MCP extension. You can host those tools from Data Connect using GenKit as an MCP server itself.
Okay, so that is that piece. Okay, cool. This is awesome. I'm excited about it.
So we're going to start and build a new app. And we're going to actually show kind of the new things that Gemini can do for us. This is a new, Coding Calc demo. I started a new service, and I'm clicking Getting Started with Gemini. And one of the great things is I can either start with a code lab, right, if I want to learn the ins and outs of the product. I can skip schema generation and go straight into the product, or I can talk to Gemini and it'll let me, it'll generate a schema for me based on the app that I describe. So in this case, we're going to create like kind of like a movie review app that tracks reviews, actors, and movies. And there we go. Gemini actually generated this kind of new schema for me. So I have users for my application. They can leave reviews. You'll notice here it's got an ID field, but it's also linked to movies and user IDs. It's got a movie cast, movies. It's got actors. Now, this is pretty good, right? And you can actually go and modify, right? This is like, let's make this at unique. We can make tables unique now by going and making manual modifications. We can also modify that here, right? We can modify the email column, and that's not nullable. We'll make it required. So that's something else you can do here. And you can also ask Gemini, right? Okay, I think we want a chat capability. Let's add a chat capability for users. And the great part here is Gemini will just add those updates into this existing schema and continue refining for us. So we think this is one of the best ways to start going with Data Connect because, right, you can kind of get into the meat and bones of like how you want to design your app. And the schemas that it creates, I think, are actually really high quality, right? It's a really good starting place if you're building your app from the get-go. One of the things that you can do is with the MCP server integration into Studio, this API that we're calling that generates the schema is available in Studio as well. It's not just available in this onboarding flow. And so one of the things you can do with the app, like as you get your kind of front end app built up with Studio, you can say, hey, like, please take my blueprint and turn it into a schema. And that's where you can kind of start integrating those pieces. Once I feel ready, I can deploy. I'll get a new Cloud SQL instance. And we kind of fill this out for you. The defaults are good for me. And we're off to the races. So one of the things that will be available by the time this podcast is out is that we will now have an ephemeral database, which will allow you to kind of jump right into data and start, modifying that data, seeding data, querying with your new schema, which currently isn't available today, right? You notice the red dot on operations. The red dot's going to move over to data and kind of let you hit the ground running. We've created a movie app. Now, we get to the part where I have to start building the app. And I don't think we have, unfortunately, the time, Alex, today to live code a full app. So I'm going to switch over to the actual application that I've built here. And you'll notice this is our schema, actually pretty similar to the one that Gemini created, right? We have movies, we have actors, reviews, users, roles, we have recorded watches, and we have movie stats. Now, if I wanted to go, for example, look at all the actors, I can just click the View Data button. This takes me over into the Data tab itself, automatically executes the query to pull all of the actor fields, and then gives me a table view, which is new. We used to only have this JSON view, which was, I think, really hard to read. But this table view is great, right? It kind of lays it out and lets you scroll through all of your users. You can also go in and, right, we can go look at movies. Movies are going to look a little bit different because the embeddings are ginormous. But because they're so big, we can actually go in and expand and look at these embedding objects. These embeddings are for vector searches. Alex, how much does your audience know about vector search?
I think we need to kind of skill up on vector search. This is what it is. If things are related to each other, they will end up closer in a database. And that's what that crazy stream of numbers is that comes out, so it can find it.
And it adds things that are semantically similar together.
Yeah.
So if I'm talking about, if I'm a travel company and I've got a bunch of beach destinations, if someone looks up volleyball, that'll end up with my beach destinations instead of my mountain destinations, because it's more, the beach is more closely related to beach volleyball.
There's a couple Firebase videos out there that I think does a really good job with this, so I'll link them up here or in the description. I know a lot of people are interested on like straight SQL. Can you make an actual like select star from blah in this context as well?
That's a great question. We have something called SQL Views, which let me see if I can show it in here. Yeah. So you can write just raw SQL with these SQL views called @view. And the team is actively developing a way for us to, instead of kind of creating these views, which you can then use and like join on, we are creating a way for you to just call using raw SQL straight away in these queries. I can't show it to you today, but it is coming soon, I promise. And I'm pretty excited about kind of what it'll unlock, because while this is great, this kind of table definition with like a view, it is not as easy as just writing a bunch of SQL in there.
Yeah, I think a lot of my viewers at least have checked out Superbase quite extensively. So like, I'm sure they're like eating up this video like feature to feature, like what's offered, what's not. So that's cool.
Maybe I'll be able to come back on in the future and we can check out some SQL.
That sounds awesome.
We talked about defining queries that power your application, and we actually call those operations. So these are actually all of the queries that have been defined that power my application. You'll notice here that there's the type, right? It's a mutation or a query. We have connectors here. We have the auth policy, right? This makes sure that like the user has to be signed in order to access it, and these are publicly accessible. And it actually also tells you what relevant tables are involved here. And this talks about the parameters that you pass in. So this is kind of like your like kind of one-stop shop for viewing what the API is available. And you can even look at them, right? So if I go look at add review, this is my mutation with these different fields here that lets me take a look at it. I can also go in the data page. Actually, and one of the things that's great about this is we've added this download SDK button. So this is a command that you can run that will generate your SDKs for Android, iOS, or web in a new file structure within your local machine. If you have already built out and started locally, like I have, we have tools that will generate those SDKs automatically, but this is kind of a great way to hit the ground running with that download SDK button.
That might be a good bridge then. If you're in Studio and you're like, hey, I'm in Next.js, I already have this thing, go run this command and get started instead of kind of the reverse. That's cool.
And the nice thing about Studio is once you have the SDK, the AI is actually quite good at plugging it in. It's nice because it's like, oh, you've generated these types. I know this is what the object looks like. Okay, I can build around that. And that's, I think, one of the nice benefits.
Do you mind if we spend just 1 second on kind of that auth policy a little bit further? So to understand these calls, realistically, you can almost think of it as a GraphQL kind of at the top level, and like the user access versus public access. It's not necessarily like at the row or table level. It's kind of that API layer above it that's preventing that. Is that correct?
Yes. So it's actually a hybrid of both.
Okay.
This is what you're talking about, this auth directive at user. Let's see if we can make this a little bigger for people to see. So at auth level user, which means the user has to be logged in, and the credential has to be passed along when you call this mutation from a client app. When you insert it, right, you actually pass in the UID, and so that way it's saving the review to that user. You couldn't save a review to a different user.
Sure.
And so one of the things that we really like here is the Firestore model is great because it lets you write any query and execute it from any client. But then when you write security rules, it can be a little bit challenging because you have to think about all the ways that data in that collection can be accessed. Absolutely. Here, we wanted to put those two things together, right? You pass in the user object, you do the filtering based on that user, and it all happens in the query. So the security is more at like the query level instead of at like the underlying collection level. And that actually it makes it easier to reason about because you just have to think about all of the different queries. And that actually is kind of your security surface. There's no arbitrary queries that a customer can run against your backend. It's only the ones that you've defined here.
So something that's common in Firestore and security rules, you might have like a table where it says like admin or you're part of an organization and it's like a secondary lookup to get into that call. Would you do that like on the SQL side of this, or is it up a level from there? And if I'm not asking it correctly, I can rephrase.
No, that's a great question. So there's multiple ways that this can be done. So you'll notice here, right, like that you can actually write expressions in this auth directive, right? Expression auth UID is not equal to nil, and that the sign-in provider is not equal to anonymous. You can also write like, the auth claims are passed in. So you can check if the auth claims are admin and only give that access to that query if they're an administrator using the auth claims on the auth object.
That's cool. Nice.
The other way to do it is you could have a table, right? You could have a couple of tables with like different roles and permissions, and you can build into the query. There's a directive called @check, which I don't believe is actually in this sample. And it lets you, before allowing a query or a mutation, you go do a lookup in another table to see if some data matches something in the auth token.
Okay. Fantastic. Yeah, I always think of like, people signing up through Stripe to use, AI to like hit something in and they run out of tokens or whatever. Like there's kind of a little more to that lookup than just are you authorized or not. So that's fantastic.
Yeah. And one of the things that we like about @check is that we want it to be compatible once we start adding additional ways to talk to other data sources. So in the future, you'll be able to write @check. And like if you want to go look up something in the Stripe API to authorize access to something in your database, you could do that.
Cool. That's great.
So one of the things that's great is we have all these queries that we've run that we got from the data page. You can actually go to your operations. You can run your operations right here just to test them out inside of your console. So we are going to try looking up actors. I know we just looked at actors, but we'll look at an actor page. And so you'll notice one of the things here is it actually included a fragment when I added. So we're here in the docs page, we went to operations, and it actually included this fragment. And these fragments are really powerful because instead of kind of rewriting the return object every time from a movie, we just return a single type of object, right? Movie overview. It includes like the stats, and it's actually under this movie stats on movie. It's actually doing a join on the movie stats table under the hood for every movie object. And so when we look at this actor page query, we get like kind of the actor fields, but then we want to pull the movies that are related for that actor. And what's great here is that we can use this ... kind of syntax to pull in these fragments so we can use this movie overview with multiple different queries. You'll notice, right, if we go to the home page, so we have a review fragment as well. And you'll notice, right, new releases. Here's all the movie overviews, top movies. We're going to use that same fragment. For recent reviews, we'll use the review fragment, plus we'll have the movie fragments that those reviews are linked to. So this actually makes it really easy for me to like kind of think about these like entities for my front end that can be used across multiple different queries. And it makes my life a lot easier as I'm writing these queries because I don't have to kind of duplicate anything or make sure things are aligned.
And you get all the nice TypeScript, like client calls with those names. Like you can just say client.homepage, or I can't remember it exactly, but something like that.
That's exactly it. To get the actors, one of the things you can do is you'll notice here that this takes a string of the actor ID. And so we can actually inject variables here. And I've already pulled up my favorite actor from this database of fake generated actors.
I thought we were going to get a hot take from you, Tyler.
And you'll notice here, right, we pull Madeline Lewis, and she actually has not been in a single movie, but has been an actor since 1940. No, she was born in 1940, but not in a single movie. I'm not really sure what Gemini was thinking when they generated this one. But we did create a photo for her.
So she's around. That's good.
Yeah, she's a person.
Yeah.
according to Gemini. This is VS Code, where I am running my application. I've actually already started the emulators, which has the Data Connect emulator, which is connecting to a local PG Lite instance. Do this to start up my web app. And so you'll notice it's on localhost. And this is my movie app. Inside of my movie app, right, this is actually, as we saw with that homepage, is right, new releases, top rated movies, and we have the recent reviews with kind of the image of the movie that is related to from that query that we just saw. You'll notice we can click in and go look at a movie, right? It's got the cast with all of these kind of fake generated cast members. We've got a description. We've got a bunch of reviews. We can log a watch, right? So Alex, did we like this one?
Oh, we loved it. Yeah.
We loved it. Where did we watch it?
On the beach in Jamaica.
All right. We watched this at a theater on a beach in Jamaica and thought it was uplifting. So we've now added that to our watch history. You notice here I'm actually already logged in to my user account, and we can go into my watches to go see, and we just watched Stapler Shenanigans. So this is actually all running on an emulator on my local machine. So all this data was kind of piped in as demo data. And so we looked at the homepage query already, but let's go look at the different searches. We talked about full text search being really powerful. So we'll go browse really quick.
Cool.
And you'll notice this is kind of a basic text matching search. So if I type in color, right, we should see the color of feelings, the colors of goodbye. If we type in color like lowercase, it actually doesn't match anything.
Oh, wow.
If we type in the, it'll match like everything that starts with the, which is like not actually very helpful for us because it doesn't mean that much.
Is this using full text search, or this is kind of just query params on titles type of thing?
And I'm glad you asked. We're going to go look at that query right now.
Awesome.
And figure out what it is. These are partial title matches. And so we omit this kind of for all titles. And this is where it's saying it's just running a contains on this partial title match. So it's not a full text search. This is kind of like the basic, like, string contains in Postgres. And was okay.
Yeah.
Right. This is actually the query that we ran. It has a bunch of different parameters, and it's actually what powers this page with all these movie overviews. But I think we can do better. We are back here, and we can do a full text search. We'll look for the again, just as an example. And full text search actually doesn't index the because it doesn't think it's like a strong enough word to use to identify.
Right.
We can also look for love, and we'll have a bunch of different love options. But we could also use like a lowercase love, and this will still return the same results.
So I'm really
And
curious, like always you on the far left, love is not in the title. That must be pulling from a description.
that's exactly right. And I'm glad you asked. We can actually go look at our schema really quick.
People are going to think like I have these prompted questions, but it's just like you must have this demo set up perfectly for me.
I, I was just thinking of you when I was setting this up, you know?
Perfect.
So you're exactly right. So we've done is we've added this at searchable tag on the title and on the description, which means when I run a full text search, I'm not limited to a single column. I can actually search across multiple different columns.
That,
And this at searchable could be applied to even more columns if I wanted to.
that blows my mind. That's all it takes.
Super easy.
It's not so at the table level, do you have to create anything at the query level to say you're using a searchable field, or what does that look like?
I'm glad you asked. So if we go, I called this FTS. There we go. Search movies, full text search. And you'll notice here, we actually have 3 different types of full text search queries.
Interesting.
We have the query, the plain, and the phrase, which we'll go into the differences. But you'll notice here that it's just called query, right? This is like a new type of directive that does a full text search on movies. It's the underscore search with the query. And this is how we're defining it. Query, plain, and phrase are the results. And we just need that underscore search. And that will use all the searchable fields. So at searchable, you use underscore search to search through those fields for full text search.
Is there any limitation on field types to add searchable, or is it wide open?
I do believe there are limitations. I'd have to check the documentation to give you the full rundown. But I think, searching through vector, like indexing a vector field or an embedding field for vectors, I would not recommend. Okay, so these are our 3 different searches, and let's figure out what the difference is between the 2. So let's see, let's try love potion. Okay, so for plain text, right, this is methods as search terms. And so we have kind of love potion. It's really good for general searches. Phrase search means it has to match the phrase exactly. So you'll know love potion is here. And then the query string results lets you add operators to add additional logic. So we can actually demonstrate what that looks like right now. So let's say I do potion love. So plain text search, right? It doesn't matter. The order, love potion still comes back. For the phrase, because it's love then potion, this is not going to work. And for the query string, this did work. So one of the things we can do is we can add this operator. Let's add the not operator. So we'll just add a minus in front of potion. And so you'll notice plain text search, still love potion, doesn't understand that operator. Phrase search results, also exactly the same. Nothing goes, potion love. But our query string results now show everything that has love but doesn't have potion.
That's cool.
And this gives you incredible flexibility, right? You'll notice love potion not here. It gives us incredible flexibility with what we're doing our searches for our data, and it helps you deliver better results to your users.
Is there any capability to get cached phrases out of this as well to kind of speed up performance, or is it kind of more reliant? So I'd use a tan stack query and use some caching on that side instead, or is there something on the kind of back end side that might cache these?
So in terms of performance wise, the tan stack one, I believe we have that integrated out of the box. And then for the backend piece, I think it depends on how you want to optimize it. There are some advanced settings you can do to improve query performance and optimization. And we actually have some more kind of tools to tweak, advanced settings coming soon, which we're pretty excited about.
That's cool. I'm just thinking even in Firestore, and this is the difference in schema based that people probably should understand. If you're doing kind of searches across or weird combinations, it's going to say, hey, you need an index. Whereas on this side, when you're using Data Connect, you're kind of building those out in the structure ahead of time. Well, at least in your query, you're building those out so it already has the understanding of things that you need. There's nothing really today that would require something in addition that you haven't thought of. Is that true, Tyler? Or do you think maybe I'm missing misunderstanding that a little bit.
No, I think that's right. And let me see if I understood what you said. There's nothing additional you need, right? As long as you put in that at searchable and you use like the search query functionality, like that builds those indexes for you and lets you hit the ground running.
Awesome.
You may want something that's a little bit more intuitive, right? That understands what the intent of the user is trying to say. So, right, Love Potion is great. It gives us some great results here. But what if I said, like, I don't know, Love Tonic, right? Tonic is another way to say potion, right? It's kind of a semantically similar word. But full text search isn't going to match that because it actually has to have the word in it. But this search movies up here actually uses our last one that we've been alluding to all this time, which is a vector search. So if I type in Love Tonic, the vector search will use those embeddings we had on movies, which have taken the title and description and generated an embedding using the text embedding gecko 005 model from Vertex. And we pass, and we'll actually show how this works in code. But you'll notice here that Love Tonic resulted in Love Potion because they're semantically similar. And this can be really good to use to like get the user's intent and then execute a query based on kind of the intent of the user.
That's incredible.
So yeah. So we've seen 3 really great ways to like, kind of the manual search we saw in Browse, the full text search where you have like different matching options, and you have vector search, which allows you to get the semantic meaning of the intent. So sometimes there's different use cases where each one will be valuable. And the great part with Data Connect is you can mix and match as you choose.
That's so cool. I'm so happy you showed all of the different versions off too. Great explanation. This is so cool. Yeah, I'd love to understand, maybe this is where you're headed, but like when you go to add a movie, what takes place to like create that vector embedding, and like how long does it take and things like that?
That is a great question. In our movies, let me see. I actually don't think I have add movie on this demo because we've generated all of the movies. But we can actually see what that embedding generation looks like in the search movies section, because you need, in order to do comparisons with that movie, you need to actually generate an embedding in order to do the comparison. So I typed in Love Tonic, and when I did the query search movies, you use the underscore embed direct field. So compare underscore embed. We pass in the query, right? That was Love Tonic, and use this text embedding 005 model, which will then automatically be passed to Vertex AI. It will take that query and it'll turn it into an embedding.
Wow.
It'll then do a comparison, right, using the embedding similarity search that we have built in here with movies. And that will do so it'll take that query that we've just generated with the embedding and compare it to all of the embeddings in the movies field. And it'll return the ones that are the most relevant. It'll give us, we decide to limit it with 10. And you can actually tune the sensitivity, right? There's how close things are, right? Because if we typed in something like the history of, 1800s moves to California from like the East Coast, right? Like the settlers. If there's no movie related to that, maybe we don't want to return a result. And in order to do that, you can tune the accuracy of the like how similar things are, like how far the distance is between those vectors, which gives you kind of a nice flexibility of like, okay, I should return, even though the limit's 10, maybe sometimes it'll only return 2 results because those are the only ones that are close enough within our distance parameter.
This is kind of typically what they call top K, is that?
Yeah, you can think of the vectors as points within like multi-dimensional space. And that distance between them is measured as like kind of where those vectors are in space between each other.
I guess the limit part, I'm just wondering if like that is actually saying that distance away in the vector, or if the limit 10 is just saying, I've found 100 that are all within X, range away. Give me the top 10.
That's the second one. It's the second one, yeah. And we actually don't have the distance parameter listed in here for this demo, but you can find it in our documentation.
So I'm going to talk through this, and it's going to be really bad because I still have it not working in my head. I add a movie, right?
Yep.
I don't have kind of all the metadata around it or the embeddings or anything like that. Upon adding, is there something that runs at that point that actually creates all the vector embeddings, or is this like dynamically happening during search?
It happens, and we actually store it in the database. You can actually check out our code lab,
Sure.
and it has vector search in it, and it also uses movies. It's a different model than this demo that I'm using today, but there is a mutation that you run that will add all of the embeddings, and it's actually very similar here. It's used I believe it's generate underscore embed, and it'll create. You pass in like the description plus the title and the model, and it'll store that embedding.
Okay.
And that's actually what we saw earlier when we executed the movies. So if we go back to the schema, click View Data on Movies. These are all the embeddings that are permanently stored in the database. So this is that giant vector and multi-dimensional space we were talking about. These vectors are, 768 different dimensions large. These are permanently stored with these movies, so they can be searched on that field for. So we generate these at the time of creating the movie. You pass in the title, and we've passed in the title and the description, and then we've generated the embeddings based on those two.
Okay. And later, according to that, let's say my model was okay now, but like there's a better one that's come out. So you would kind of want to run through, whether it's a function or something like that to update all of those with a new model. Is that kind of how that would work?
That's exactly right. So moving to a new model is challenging, to say the least, right? The way you'd probably have to do it is you have to probably create like a new embedding field so you don't break your live app. You'd run a migration on all of your movie entities to add all those new embeddings. And then you'd add a new search field that searched on the new embedding column, and and then you could deprecate the old column.
Sure.
Once you find the right model, you'll probably want to apply it to your broader database and stick with it. Right. And so this kind of becomes automatic for you as a feature. It means that you're not necessarily like the data that you pass in can also be restricted with Gemini, so it doesn't learn off of it. And this way it keeps that data private within your database.
Yeah, that's a great call too.
We haven't shown off what the MCP tools are that you can use. So we're actually here in VS Code, and I'm here in my queries file. We've had the Firebase extension running this whole time. And one of the things you can actually do is you'll notice these code lenses here. We can actually run these queries whenever we want, right? Just to test them out locally, which I think is really nice, right? Like you can write your query, and then instead of waiting to submit it, you just use the code lens to run it against your either production instance or against your local emulators, which we're running right now in the background. Here is my query, and then here are the results for that movie that we just looked up on the movie page.
It's really cool that you can kind of, and this is the power of GraphQL as well, is that you can ask specifically what you're looking for, do all the joins kind of behind the hood. So like you're not passing too much data over, you have the security surrounded it. I find it's really powerful on top of this. That's really cool.
Yeah, and I think that's one of the things that we loved here is that giving that, using the power of that GraphQL here to not only have this flexibility, but also define the strongly typed objects between your kind of client app and your backend gives you the structure that's helps you rapidly iterate and build as your app grows. Alex, what would you say to folks who may be worried about adopting GraphQL?
Oh, interesting. There are some learnings that you have to get into. So when you are living more in the REST world, like a get call and kind of how it works, and a put, a post, like all of those different methodologies. With GraphQL, it's all post calls, if I remember correctly. And then you're always going to have kind of like queries that are required for those on top of it. So it's a little bit of a learning curve on that side of it. I think that the power of them, though, is how much you can actually do in a query as well. So like you can chain together 5 different things you want to occur in a single call.
That was great, Alex. Right, like that. And I think there are some differences with GraphQL. Is it worth learning?
Ooh, yeah, I think so, for sure.
Cool.
I think that in my mind, from a Firebase user, and I've used a lot of different tools over the way too many years at this point. I'm turning very gray. I think the coolest part about the GraphQL side and kind of the story of what Firebase is trying to accomplish by doing this is that it still allows you to easily get into these things instead of like someone would typically in this scenario have to stand up all of those SQL tables, writing raw SQL, right? And then you would have to put a REST API on top of that, and then security on top of like all of a sudden you're like, man, that's like 3 months of work. Whereas like this, you're kind of like, here's my schema and how I want my queries set up, and like it's gonna go build all of that infrastructure for you, and also be in the Firebase ecosystem, so you can start to like actually access and things like that. So does that make GraphQL worth it? 1,000%.
Yeah, no, and that warms my heart to hear you say that. I think one of the things that we've done too is the GraphQL flavor we have is a little bit different and hopefully a little bit more approachable. And one of the things that's nice is you can actually use AI to help you write your GraphQL queries, which is a perfect segue into that MCP segment that we were looking for really quick. MCP can be integrated wherever. This is integrated with the Gemini VS Code extension. It's also available, right, if you want to integrate it into Cursor or whatever, the Gemini CLI itself. All of those can be pretty easily integrated. In this case, it's got context, so it's using my queries file right now, and it will also pipe in my schema file from using the MCP server. And so I can say, can you show me all the reviews for a certain movie, right? And that's like pretty natural language. And Gemini will then think, it'll realize that we're using Data Connect. It'll go reference the schema to figure out how the schema is designed. It'll reference the kind of generated GraphQL that gets pulled up in the backend. And it'll then be able to craft a GraphQL query, hopefully that matches my intent. Right? And you'll see here it's kind of reading these files. It read our Data Connect file, so it knows we're using Data Connect. Of course, what is the title? The movie's ID is, and we'll do the
It'd be really interesting if you could like have it do the embedding side where you're like, I would like it to use what was the Love Tonic version? See if it like was able to like look through vector and kind of figure that out.
Yeah. Okay. Tools. Okay. So this is using a tool here from my MCP server. It's going to execute this query. So we'll accept it. And it's only once, right? You can choose to let this always go, or you can choose to approve. Wow. This actually wrote the query. This actually just did the execution and gave me the answer based on what it knew. That is not what I was expecting. Previously, it's just written me the GraphQL query, but this actually took me all the way through, used the MCP server, and just gave me the result.
I guess you did say, like, what is it? Instead of saying, can you provide the SQL for, or whatever, the GQL for it, the query for it.
Yeah, okay. Here, let's try this. Okay, can you write a query for me for all the reviews for a certain movie?
I think you might end up with the same situation. I think you might have to put like, and add it to queries.gql. Oh, just kidding. There you go.
All right. Okay, here's a GraphQL query that we'll review. Let's see how it did. Movie reviews, off public. That's pretty good. Would you like me to add this query to your, yes, please.
I've been reading a lot lately, and you and I are pretty like, please, thank you, yes, like, please, like, I've been reading a lot that like when you use models like this, not to do that, and it's kind of funny. I don't know why.
Maybe I should have been more strict.
Yeah, like I think that's, and I've tried this more and more, and saying can you, like eliminating can you and just saying do this, gotten a lot better results. It's kind of wild.
It actually looks okay. It actually shows me this diff view, which is great, right? This is like a Gemini diff. And I can accept or decline it here. And you'll notice it actually even used a fragment
that's cool.
that I had defined earlier on in the file, which is pretty neat. So let's accept this here. And let's try to run it. Okay. And there we are. This is for that scientist movie that we had. And this is all of my reviews, right? So here's the movie page for The Scientist Secret. Let's make this easier to view, right? So here's scientist secret, and now we're looking at the reviews for it, and it has my reviews on it. Isn't that great?
I love that. Yeah. I see you guys have added something I didn't notice before when I was trying this, the rerun of those, because I would be like somewhere in another file and I'm like, okay, now try it. Oh shoot, I gotta go click a button in the file again. So props to you guys on adding that feature.
Yeah, no, we've been really trying to like add kind of like small usability features here and there to make it a lot easier to work with this.
Yeah. I do want to, if you don't mind showing us. So for most people that haven't tried this out with the tool yet, that left on the left side, the code assist, Gemini code assist that Tyler was running, this might seem like a little bit of black magic to call it like, hey, there's a tool. Would you mind showing either your mcp.tools in the workspace or kind of wherever you have it?
Yes. So under .gemini, I have extensions. And here we go. Gemini extension, MCP servers, Firebase. This is all you need.
Yeah, it's great. And if you want to use it to like fully set up stuff in VS Code, you can actually use, I'm going to forget, but it's out on the documentation. I'll put it in our blog post as well. There's like a MCP file in VS Code that you can add directly to it. It looks slightly different than this, but it does the same thing too.
Great call out. And yes, that is probably the better way to do that. This is obviously a little different for the demo, but this will also work if you kind of want to just drop it in.
Yeah.
We've covered a ton of content. I actually think I have more, but I think we might be running out of time.
I think we're a little tight on time. This was incredible. I saw Data Connect in preview. I think you and I chatted at a conference 2 or 3 years ago, maybe. It's been a while. So to see where it's progressed to is pretty incredible. You guys kind of keep iterating. I'm sure you're taking a lot of user feedback. The one question I have is just when to use Data Connect versus Firestore.
That is a great question. Data Connect or Firestore? The question really comes down to the kind of app you're trying to build and the tools that you're going to need. If you are building an app that doesn't need like relational joins or like really heavy analytics, right? Firestore is going to be your bread and butter. It has real-time sync. It has amazing offline support. If you are building an app where someone is going out of signal and needs like to be able to write stuff offline and have that upload later, Firestore is 100% it. If you need something where you need really strong query capabilities, if you need that kind of analytics backend and you want to use all of Postgres's great extensions, Data Connect is going to be your bread and butter. One of the actually great things that I've done before is I've actually asked Gemini, when should I use Data Connect in SQL versus Firestore for my apps? And it's actually been able to give me a pretty good readback of like when I should use one or the other. So I actually highly recommend giving that one a go.
That's a great idea. Well, thank you so much, Tyler. I really appreciate it. I know there's a ton more content that we can get into, and I think there's some new features headed our way later on this year. So kind of excited to get to those too. So check out the rest of the content that we have surrounding Data Connect that's coming out that I've put out. And we'll see you guys next time. Thanks, Tyler.
Awesome. Thanks, Alex.